All right, let's take a look at number 7 from the calculator section. Here they want us to find all solutions, not just over any given interval, like we usually see 0 to 2 pi. In this particular problem, they want us to find all of our solutions. And because we're trying to find all of our solutions, it's going to be a little bit easier to determine our period if we get rid of that sine squared and instead work with sine of 2x plus pi over 2. So as you can see here, I took the first step of taking the square root of both sides. So I was left with the equation sine of 2x plus pi over 2 equals plus or minus 0.731. So now that I have this, I'm not super comfortable when I see these ugly decimals here. So what I want to do is grab my graphing calculator and try to solve using that. Now here you see in my y equals screen, I have sine of 2x plus pi over 2, 0.731 and negative 0.731. Just graphing each of those individually. So now I want to make sure that I am in the correct mode. I am in radian mode, and I'm going to set my window from 0 to 2 pi. Now I know we're going to find all of our solutions, but using this 0 to 2 pi, it's going to just be a little bit more clear where our solutions exist and how we can project them out beyond just this particular window. So I'm going to go ahead and graph this. And you can see our sine graph is here in red, and then our positive and negative 0.731 have also been graphed. So if I wanted to solve this, I would second calc, and I'm looking for intersections. And what I'm going to do is I'm going to find the first 4 intersections. You can see we have one here at 0.3755 or 0.38. We can find another intersection down here at towards the bottom of our graph. Oh, sorry, I repeated the same one. If you notice here, it's a little complicated when we have multiple lines. And if you see here, I have that cursor on the top line. I want to hit the down arrow. So now that I'm trying to find the intersection of the appropriate line, there's another solution at 1.20. I'm going to keep going through the same process. Here we have our third solution. Sorry, I made the same mistake. That we have another one at 2.77. And then our final intersection point, hopefully this time, is down here. And I'm going to hit the down arrow. And I have 4 solutions, right? I have the 1, 2, 3, 4 solutions over the first period. Now, what I've hopefully you notice here is that this solution here, if I have my cursor here, I'll try to highlight it a little bit more clearly. This solution here is one period further down the sine curve than our first solution. And then this solution down here is a period later, than our second solution. If we keep going, there's our third solution, one period later, and our fourth solution, again, one period after our solution up here. So based on what we see here, as well as our formula itself, we know that our period is 2 pi over this b value, right? This 2 that you see highlighted here. Well, 2 pi over 2 leaves us with a period length of pi. So if I wanted to find my solutions, all of my solutions, from my graph, I have my 1, 2, 3, 4 decimal answers. And I would take those first 4 decimal answers, and each of them I would add pi times n, where n is an integer value. So plus any value of n will kind of repeat each of those 4 solutions. So if we jump over to our answer key, we can see those first 4 decimal answers, 0.38, 1.20, 1.95, and 2.77. Each of them we would add n times pi. So that would be our solution set for problem number 7 on the calculator part. Thanks.